One of the things that we talk about on the practice test that we haven't talked about in class is some of the technical terminology that's introduced in the reading. And so one important bit is the idea of a variable and a metavariable, and a language and a metalanguage. In the chapter, I give a definition of a sentence in SL, and I do that with a fair amount of rigor, mathematical rigor, which means that in order to do that, I need to have additional mathematical symbols that aren't a part of SL. Think of it this way. We are building an artificial language, SL. When you build things, you often need to create a scaffolding around the thing, right? The scaffolding isn't part of the house you're building, but it wasn't there to begin with either. It is artificial. It's something you use to build the house and then you take down. The meta-language is the scaffolding for SL. It is something that we use to build it. So what we say is, with SL, these letters are variables, right? They stand for any sentence in English. So for instance, we have a sentence like B, and the sentence B could stand for, my dog has fleas, the cat sat on the mat, the murder of logician Richard Montague was never solved, and elves live in tunnels under Stocker Center. Sentence 3 is true, sentence 4 is false. Right? But all of them can be represented by B. Our scaffolding, our meta-language, includes these meta-variables. So here, a sentence like B, and here I use script, the scripty font, and that can stand for any one of these sentences. So it can stand for A, it can stand for B, it can stand for C and D, it can stand for not D implies E, it can stand for, any sentence of any arbitrary length. We use these meta-variables so that we can create definitions of things in SL with rigor, right? So our meta-language consists of ordinary English plus these meta-variables and some other symbols. Okay. Right? So if I say in English, or if I say in the meta-language, any sentence of the form A and not A is a contradiction, right? And that's something I will tell you. It's something that's obviously true. So here's our smiley face making this assertion in the meta-language. That is a statement about the object language. It covers all of these possible sentences in here. Now, none of these are of this form. Therefore, none of these are a contradiction according to that statement. But still, it gives you a sense of what's going on here. The meta-language in blue is about the object language in red, the one that we are creating. All right. Oh, and I need to change this because I'm no longer using the terminology well-formed formula. I'm now just saying a statement in SL. Sentence in SL. The other thing that we do in creating our formal language is we use something called recursive definitions. And for those of you who want to go on and do anything in computer science or computability theory or that branch of what we're talking about, these become extremely important. A recursive definition is a kind of definition where you define a base class and then define rules for expanding on that base class. And we're going to use our metalanguage to create the recursive definition. Okay. So every recursive definition contains three things: a base class, rules for extending the base class, and then a closure rule that says only things in the extended base class fall under the definition. And you can see that in our definition of a, oh, and this is still old. Now, on this slide I'm saying woofs, but I don't use that terminology anymore because it just added, it was one more thing for people to memorize, and you don't need to memorize it yet. So I need to delete here where it says WFF and replace that with sentence. Mentally, you're going to just have to do that on your own. Fix PowerPoint 4. All right. So what we do is we say that our base class consists of these sentence letters, right? And then we say if any sentence A is a sentence, then not A is a sentence, right? So this lets us expand here. We can go from A to not A, but we could also go from A implies B to not parenthesis A implies B, right? And that still is a legitimate extension of the class. So we've got 5 rules, one for each of our connectives, that says that you can build on your base class using that connective. And then your closure rule just says that the base class and strings formed from it using the extension rules are all sentences. So this is how you have to imagine things going. Here's your base. You've got some letters, and you just start to put them together. So if A is a sentence, not A is a sentence. If D and E are sentences, then D implies E is a sentence. And if those two rules are sentences, then this is a sentence. This is important. This isn't, this might seem technical or confusing, but you need to grasp the fact that these things are built up this way because we're going to use this structure in Chapter 3, right? So the important thing here is that the last connective we added is called the main connective. That's going to be an important term. You saw how this was built up, right? We put on this, then we put on this, and then we put on this. The last one added is the main connective. That is going to be something that you need to know, not for this test, but for the next one. We're going to be building on it, right? So the main connective is the last connective added when building a sentence recursively.